SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering basic and applied. Today we shall discuss about the boilers. In fact, we have discussed several cycles which are used to describe all the processes in a steam power plant, and we have seen that all these processes can be mapped in different thermodynamic planes. Mapping all these processes in thermodynamic planes, in particular PV and TS plane, we could establish the thermal efficiency of the cycle. Now, we have seen that thermal efficiency of the cycle is not only the efficiency which dictates the overall efficiency of the plant. So, if we try to find out what would be the overall efficiency of the plant, we also need to understand the performance of several other components along with several other efficiencies which are also important to be looked at. So, now if we go to just before I go to discuss about the classification of boilers, their working principle, let us first draw the schematic depiction of the plant. From there we shall try to understand why we need to specifically study about boilers. So, if we try to draw the schematic depiction of the plant, so this is boiler, very simple one that we have discussed several times. So, this is the most simple schematic depiction of the steam power cycle or plant, and what we can see from this depiction is that there are four major components: boiler, turbine, condenser and pump. So, this B is used to denote boiler. Similarly, we have several other components like turbine, condenser, pump. We have discussed all these, this particular description of this particular diagram. Now, what we would like to discuss today, we have discussed about thermal efficiency of the cycle, that is nothing but W out by Q in. Question is, this is the thermal efficiency, and by knowing only this thermal efficiency, it is very difficult to predict what would be the overall efficiency of the plant. So, if we look at why, I will discuss later. So, the overall efficiency of the plant it is thermal efficiency into mechanical efficiency into generator efficiency into eta boiler. So, you can understand, if we want to predict the overall efficiency of the plant, we also need to know 3 different other efficiency together with the thermal efficiency that we have already discussed. So, this mechanical thermal efficiency that we have studied, and we have worked out numerical problems as well. So, this is the efficiency which is, which comes into the picture accounting for the the efficiency of the turbine or pump, because if you try to look at, this is the amount of energy that we are going to add in the cycle, and out of this input energy we are also getting some amount of energy in the form of work, and this is basically, if we look at, this is, though this is W out, but ideally it should be W net out. That means, this device is also taking or consuming some amount of work from this output work, and as a result this W net is coming into the picture. So, now to take care of the efficiency of these 2 devices, this thermal efficiency is coming into the picture. What about this mechanical efficiency? This is also another important efficiency. Perhaps you have studied in the context of pumps. So, you know that the energy which is being developed inside the turbine, that energy is not available at the shaft of the turbine. So, some mechanical losses are there. Accounting for these mechanical losses, we also need to define one efficiency, that is mechanical efficiency. So, that means the energy which we are getting, so when steam is flowing through the turbine, it does work on the rotating part of the turbine. So, energy is produced, but that energy is not available at the shaft of the turbine because of some mechanical losses, and that is why this mechanical efficiency is coming into the picture. So, we have talked about the thermal efficiency, we have now discussed about mechanical efficiency. As such, I am discussing why, because you should know why overall efficiency is important. Third is the generator. So, efficiency of the generator. You know that even though some amount of energy is available at the shaft of the turbine, next this part, so this shaft is also connected to the shaft of an alternator, from there you are getting electricity. So, from this part onward, so this is the common shaft, and this shaft is also connected to the shaft of an alternator or generator. So, this is alternator, right. So, the shaft which is the work which is available at the turbine shaft, that work is not going to produce equal amount of electricity, because some losses will be there. Perhaps you have studied when you have studied about electric motor and etc. So, windage loss will be there. So, bearing loss will be there. So, accounting for all these losses, this efficiency, that is generator efficiency, is coming into the picture. So, fine, we have discussed about thermal efficiency, we have discussed about mechanical efficiency, we have discussed about generator efficiency, but in addition to all these three efficiencies, we are also having another important efficiency, that is boiler efficiency. So, it is equally important to be looked at while we are trying to predict the overall efficiency of the plant. Why? Because when someone is designing several components which should be placed in a thermal power plant, even after incorporating all these devices in all these components in a power plant, we also need to calculate the overall efficiency. So, whoever is going to design the plant, then I mean he or she must be considering the overall efficiency. If he or she needs to calculate overall efficiency, in addition to all these three efficiencies, this is very important to be looked at. So, this is boiler efficiency. Now, question is, what is boiler efficiency? See, if you look at the schematic depiction, what we can understand, let us first draw the TS diagram, then it will help us to understand exactly what we are going to discuss now. So, if we will draw the TS plane, right. So, this is, say this is the Rankine cycle, modified Rankine cycle, that is steam is superheated beyond the saturated state up to 3. So, now question is, if we look at the schematic diagram vis-a-vis the corresponding TS diagram, what we can observe? You know that we are supplying Q in. So, this is the amount of energy you are going to supply in the form of heat, and that is coming by burning from the combustion of coal, if it is the coal fired boiler. If it is a diesel fired boiler, then this energy will coming from the combustion of diesel. So, whatever is the case, we are going to supply some amount of energy in the form of heat, and at the cost of that input energy, we are getting some amount of energy recovery. Why I am using the word recovery? Because the amount of energy that is being added to the boiler is not going to convert an equal amount of energy to increase the energy of the working substance that is allowed to go through the boiler. So, the amount of energy that is added to the boiler, that energy would be utilized to convert water into steam, there is no doubt about it, but question is, there must be some amount of leakage of energy inside the boiler. So, accounting for the heat loss from the boiler surface to the surroundings, heat leakage, all the energy which is supplied by either by burning coal or by burning diesel or any other fuel, it is very difficult to have equivalent conversion. So, that means it is not the conversion, of course, conversion I would like to say, because this thermal energy is again going to increase the total energy of the steam. So, basically I should say internal energy of the steam. So, but since there will be losses of heat while it is added to the boiler, some amount of heat will be transferred from the boiler surface to the surroundings, some amount of heat leakage will be there, and as a result of which we will be getting some amount of energy recovery, but it is not equal to the energy which is added. It is because of this reason boiler efficiency is defined eta B. That means, whenever we are giving some energy inside the boiler, boiler is a mechanical device and the heat is transferred to the boiler, and using that heat water is converted into steam. So, this process is not completely reversible process, so that the amount of energy that we are going to give to the boiler will be converted equally to increase the internal energy of the steam or working substance. Because you can understand, you have studied, there is heat transfer due to finite temperature difference. So, naturally process is highly irreversible, and so long as the process is irreversible, it is very difficult to have, or it is very difficult to achieve maximum efficiency or maximum exergetic efficiency. So, this device will not run with the maximum exergetic efficiency, and that means the energy will be recovered, that is 100% true, but this recovery is not fully. So, accounting for that, we have boiler efficiency. So, what is boiler efficiency, you can understand now. So, this boiler efficiency eta B, let me write here, equal to, so while or when you are going to define any efficiency, this is something like output energy to the input energy. So, what is the amount of heat, what is the amount of energy added to the boiler, that is say m dot fuel into calorific value of the fuel. So, this is mass flow rate of the fuel, that fuel is burned, and out of this, out of the burning of the fuel, that is combustion, we are getting some amount of energy, and that energy is nothing but m dot f, that is mass flow rate of fuel multiplied by the calorific value of the fuel. So, this is the calorific value of fuel, and what is the output energy? Now, let us look at TS diagram. As I told you, in one of the previous classes we have discussed about that if we apply steady state steady flow equation to the process which is there inside the boiler. So, the process that is there inside the boiler is mapped in TS plane, and we know this process is constant pressure heating. So, this constant pressure heat addition process, and if we apply, I mean if we consider the process is steady state steady flow process, then by ignoring the changes in kinetic and potential energy, let me tell you once again, ignoring not the kinetic and potential energy, rather the changes in kinetic and potential energy, it is possible to write that amount of heat that is added to the working substance is nothing but m dot s into H3 minus H2. So, this is the amount of energy added to the working substance if we ignore, if we apply the steady state steady flow equation to the process that is there in the boiler, that is the constant pressure heat addition process, and if we ignore the changes in kinetic and potential energies, then perhaps this is the amount of energy which is added to the working substance, and that amount of energy is coming essentially from the energy which is being supplied to the boiler. But never these two quantities are equal, otherwise it would be it will violate second law of thermodynamics, because let me tell you, because these two quantities will never be equal, accounting for the process which is highly reversible, because there is heat transfer due to finite temperature difference, and also some amount of heat losses or heat leakage will be there inside the boiler. So, this is what we are getting, and the value of eta B will be always less than 1. So, this is what is known as boiler efficiency. So, now question is, we can understand that this efficiency plays an important role towards the prediction of the overall efficiency of the plant. So, our target should be, as I had mentioned few minutes back, that these two quantities are not equal. It is very difficult to achieve in practice that these two quantities will be equal. but our target should be to increase the quantity, that is m dot s into H3 minus H2, where m dot s is the mass flow rate of steam. So, m dot s, this is mass flow rate of steam and m dot f, the mass flow rate of fuel, right. So, our objective should be to increase this quantity. We know, rather knowingly we are trying that how closer this quantity will be equal to the m dot f into Cv. If we need to do so, we also need to know several processes which are there inside the boiler, several components which are there inside the boiler. That means, we need to know the configuration of the boiler, and by this time we have understood that this is the device which is again a heat interacting device. Heat transfer takes place from one stream to the other stream, right. What are the two different streams? One stream is steam water and other stream is hot flue gas, high temperature products of combustion. So, these two different streams are there inside the boiler, and when these two different streams are flowing through the boiler, they exchange heat among themselves and we are getting steam from the water. So, that means, considering all these aspects, we can understand at least it is needed to look at several components which are there inside the boiler, several flow paths through which these two different streams flow from one part to the other part of the boiler, and the mechanism by how we can maximize this quantity, that is m dot s into H3 minus H2. So, that means, if you would like to summarize, the objective behind this particular module of this course is to describe the working principle of the boiler, but before that we should understand what are the several components and what are the functionalities of several components. At least we have understood that boiler is a heat exchanger. So, inside the boiler two different streams are allowed to flow, and while they are flowing they exchange heat, and as a result of which we are getting steam from water. Now, today I will discuss about one type of boiler, that is called Babcock and Wilcox boiler, right. Now, all of a sudden if I write that this is Babcock Wilcox boiler, then perhaps at least we need it is better to discuss about the classification. So, depending on the configuration by how two different streams which we have identified, one is hot flue gas, other is steam water, these two different streams are allowed to pass inside the boiler. Boiler is classified into two different categories. So, let me write over here boiler. So, classification. Major classification. So, major classification is based on the flow configuration of two different streams. That is hot flue gas and steam water stream. So, the major classification is based on this particular aspect. Again little bit of fluid dynamics is coming into the picture, but it is not there. There is no scope to discuss about the hydrodynamics part of the boiler in this course, but at least we should know that flow configuration. So, hydrodynamics will play an important role while designing the boiler, essentially to achieve maximum performance of the boiler, but that is beyond the scope of this course. But we could understand that based on this classification, boiler can be, boilers can be, or boiler can be placed into two categories. One is known as fire tube boiler, other class is water tube boiler. Okay. So, the Babcock-Wilcox boiler that we are going to study today, in fact, I will discuss briefly, that is essentially a water tube boiler. So, Babcock-Wilcox boiler is essentially a water tube boiler, right. I guess you have understood that based on the flow configuration of two different streams, that is hot flue gas and steam water stream, it is possible to classify boiler into two different categories. One category is the water tube boiler, another category is known as fire tube boiler. So, now you can understand from the name itself, water tube boiler, what it indicates, that water stream is water or water stream is allowed to pass through the tube, and you have studied about heat exchanger in your heat transfer course, that this is a kind of cell and tube heat exchanger. So, if one stream is allowed to flow through the tube, other stream will definitely pass through the cell, that is over the tube. So, that is the concept we have studied in our heat exchanger, heat transfer course. So, this is water tube boiler, So, basically the name itself is suggesting that water will be allowed to flow through the tube, and while one stream is going through the tube, other stream has to pass through the cell. And so, that is the Babcock-Wilcox boiler. This is a water tube boiler. Now, let us come to the schematic depiction of this particular type of boiler, and that this is the schematic depiction, that is the cross sectional view. You can understand there are several components. I have labeled all those components. Not only that, I have also described all these components in the right panel of this slide. What you can see, the component is 1, components are 1 to 20 including 9 prime. So, this is 9 prime. Okay. So, you can understand that coal hopper, coal damper, chain grade stoker, S-pit, baffle, stack, drum, downcomer, downtake header, water tubes, uptake header, riser, dry pipe, convective superheater, radiant superheater, steam top valve, water level indicator, pressure gauge, safety valve, feed check valve. So, these three are very important. I will discuss in one of the in one class that there are two important I can say terminologies. One is known as accessories, other is mountings. So, the pressure gauge, safety valve, feed check valve, this is these are common to all types of boiler. So, and lastly 9 prime, that is blow down cock. So, this is blow down cock. So, if I write here, so this is blow down cock 9 prime. So, let us briefly discuss about all this, right. So, first of all we need to identify what are the two different streams. We know that there are two different streams and these two different streams will be allowed to flow through the boiler using different configuration, and that is how the classification we have discussed, and the water tube boiler is the Babcock-Wilcox boiler. So, this is, let me write here. So, this is water tube boiler. Okay. So, what are the two different streams? Streams are, one is steam water, stream, other is hot flue gas, or it is also known as high temperature products of combustion. So, this is one stream and this is other stream, another stream, right. So, let us briefly describe. If we look at this part 1, 2, 3 and 4, it is a coal fired boiler, what we can see, coal hopper. So, basically coal is placed initially at the coal hopper, that is at 1, and that coal is now dumped at 3. So, these that 3 and 4. So, there are two different pulleys through which this chain grade stalker moves continuously. So, as if there are two pulleys and chain is continuously moving like this, right. So, what is done, coal is taken to coal hopper, from the hopper coal is dumped on the chain grade stalker. So, this is the chain grade stalker, chain grade stalker. So, basically we are stocking coal over the chain grate. Chain grate that is a kind of perforated plates. So, if we look at the top view you will find like this. So, this is the chain and this is perforated plate. Chain is perforated, that you have seen. Now, as if we are going to stock coal using coal hopper and damper on this chain grade stalker, this perforation is very important to have efficient combustion, right. We need to have oxygen, otherwise combustion will not sustain. So, when that chain grade stalker is moving from 3 towards the inner end, that is the inner end of the chain grate, entire combustion should be completed. So, that means whoever is going to design this particular component or particular module of this boiler, he or she must be careful that whenever we are putting coal over here, the entire coal should be combusted within this short distance, and that is the RPM of this chain grade stalker should be decided accordingly, and entire coal would be combusted, and whenever that product is coming over here, we will be getting residue, that is ash. So, that ash will come into this ash pit in this direction, and that is shown by this arrow. So, ash will be coming and will be stored in 4, that is ash pit, right. So, that is what we have, it is shown. Ash is coming, that is the residue, and another thing is hot flue gas, that is the high temperature products of combustion. The high temperature products of combustion will flow towards the off. It is designed to direct the flow of high temperature products of combustion towards the upper part of the boiler. Otherwise, what will happen, that the combustion products will flow in the horizontal direction, it will go through the chimney to the surroundings without doing the task, that is what is important in the context of this boiler operation. And that is why this baffle is given, that is 5. So, the purpose of baffle is to provide a proper direction to the combustion products towards the upper part of the boiler, right, and also to prevent the movement of the combustion products towards the stack without doing the necessary conversion of energy. Okay. So, when the high temperature products of combustion is moving towards the off, you know that now we are coming to discuss about 7, that is drum. It contains water, water from drum is coming through 8, that is downcomer, and coming to 9, that is called downtake header, and from the downtake header water passes through the tubes, that is shown by tents. There are 3 different tubes which are shown over here. So, that water will go or move through the tubes. While moving through the tubes, the conversion will start, that is water will be converted. In fact, water conversion of steam from water starts from 9 itself. Being lighter than water, steam will flow towards the uptake header, that is 11, through pipes, through water tubes. So, now when it is again moving through water tubes, all the water will be converted into steam, and as I told you, since water is steam is lighter, it will be there in 11. You can understand that 11 and 10 or 12, these 3 different parts are very close to the high temperature part of the combustion chamber. So, this is the combustion chamber. Since 11 and 12, even 10, these 3 different parts of the boiler are very close to the high temperature part of the combustion chamber, wherein radiative heat transfer plays an important role. So, there are 2 different modes of heat transfer, one is flue gas convection, other is radiative heat transfer. Since part 11 is very close to the combustion chamber wherein temperature is very high, so radiative heat transfer will play an important role that you have studied because of high temperature difference, and the steam will move through the riser, that is 12, steam is lighter, and then it will go at the top and it will be collected at 13. Now, 13 is dry pipe, because you know if dryness fraction is very poor, then even after allowing that steam through the convective and radiative superheaters, 14 is convective superheater, 15 is radiant superheater. The purpose of these 2 superheaters, if we go back, see in this TS diagram we have tried to modify, that is steam is superheated beyond the saturated line up to 3. So, if we need to superheat, steam should be allowed to this convective superheater and radiant superheater, that is 14 and 15. These 2 superheaters are connected in series, that I will discuss later. So, you know that if the quality of the steam is not very high, then even allowing steam to flow through these 2 superheaters, it is very difficult to get superheated steam at 16. That is why the 13 dry pipe is there. The purpose of the dry pipe is to increase the dryness fraction of the steam. So, the purpose of 13 is to increase the dryness fraction of steam before it enters into the superheater. Had this component not been there, steam will be directly taken to the radiative and convective superheaters. In that case, if the quality of the steam which is being produced inside the boiler is not very high, then even after allowing them through the superheater, it is very difficult to get superheated steam. So, only to make ensure that we are getting superheated steam, the dry pipe is there. And as I told you, the purpose of these 2 superheaters is to increase the quality of the steam, and that is why they are placed almost at the middle of the boiler, which are very close to the combustion chamber. And you know 15 is the radiative superheater, because radiative heat transfer plays an important role very close to 11 and 15, while the right part of the boiler, that is part 8 and 9, here convection takes place. So, this is flue gas convection. Place. So, this is the place where flue gas convection becomes important, and this is the place where radiative transport of heat radiative heat transfer. So, basically you try to understand, if we consider baffle as the dividing wall, left side of this baffle, that is the 11, 10 and 12, where radiative heat transfer becomes important and dominating, while right part of this baffle, that is 8, 9 and 9 prime, in this zone of the boiler, flue gas convection plays an important role. So, this is flue gas convection is the dominating mode of heat transfer, fine. And then coming to the 14, I mean we have understood about 16, because from 16 we take steam to the turbine, and you know that this is feed check valve, because it is sometimes because of some losses we also need to supply water, that is called make up water to the boiler drum, because some amount of water will be lost. To compensate that water, water will not be the water level will not fall below certain point. This feed check line is connected. So, one is feed water pump is there, and that feed water pump line is having feed check valve. The purpose of this feed check valve is not to allow this is relatively high temperature water not to flow back to the pump. So, the purpose of this feed check valve is to arrest backflow of hot water to the pump, right. So, this is from the feed water pump. Okay. And 17 is the water level indicator, as I told you, that we also need to maintain a constant level of water in the drum. If water level falls, steam will increase and steam pressure will increase, that may rupture the cell. Not only that, if water level falls, high temperature part of the boiler like 11, 12, that will be exposed to steam, and the temperature of all these parts will be very high, and that may break the total system. So, basically cell wall will rupture, that high temperature will lead to generation of thermal crack. So, it is not desirable. So, 17 is it is given that to maintain always a particular level of water in the drum. 8 is pressure gauge, definitely we need to measure pressure always for the purpose of the safety of the boiler. What is the pressure inside the boiler, whether pressure is increasing or not. If pressure increases drastically, then provision must be there that some safety valve. So, by opening this safety valve, pressure should be released, otherwise it may start breaking of the entire system. So, that is why this safety valve is there. So, water level indicator, pressure gauge, safety valve, all these three components are provided essentially from the safety operation of the boiler. Last is blow down cock 9 prime. I have already discussed about feed check valve. Blow down cock is given, that sometimes that water is coming from 8 and it is coming to 9. So, water is coming through 8 to 9, then water passes through the tube. So, if normally water which is supplied to the boiler, that is purified, even after purification some impurities may there. So, that impurities may start sedimentation, sometimes that need to be taken out from the system, otherwise it may reduce the heat transfer coefficient. So, that is why this blow down cock is there to remove the impurities which are stored in the pipe as well as in section 9, so that heat transfer rate should not be affected. So, if we summarize, there is steam water cycle. So, steam water cycle, if I write 7, 8, 9, 10, 11, 12, that is steam water cycle. And what else? This 4, then 5, then 6, this is hot flue gas cycle. right. So, this is the hot flue gas cycle and this is steam water cycle. These two cycles, these two streams are allowed to flow in such a way that it is possible to have maximum heat recovery from the high temperature products of combustion. I would like to discuss one important thing. Since water is allowed to pass through the tube, by increasing the length of the tube, it is possible to have superheated steam, because as I told you that steam conversion starts from 9 itself. So, when steam is coming at 11, it is not in contact with the water, and that too the part 11, 10 and 12, these 3 parts are close to the high temperature zone of the combustion chamber, as a result of which though there is small amount of water, that water will be converted into steam. So, allowing water through the tube, it is possible to have superheated steam at the exit of the boiler, but for that we need to increase the tube length drastically. Sometimes it becomes difficult considering the space requirement, and that is why we are going to get good quality steam even at the exit of 12, but it is taken through the superheaters to ensure that the steam at the exit of the boiler will be superheated. Second point, since steam is passing through the tube, water is passing through the tube wherein steam is generated, and steam pressure is very high, steam is generated at a high pressure. Per kg of water supply 40 to 50 kg steam is generated, right. So, for high pressure, tube is good enough to withstand that high pressure instead of cell. So, had the case been like this, that water is passing through the cell and flue gas is passing through the tube, that is the fire tube boiler that we will discuss later. In that case, cell has to withstand that high pressure. So, the flow path of the steam, flow configuration of steam should be able to withstand that high pressure, and so thickness of that particular component should be designed accordingly. Since steam is passing through tube, small tube, diameter very less, so it can withstand high pressure, and this is why this water tube boiler or Babcock-Wilcox boiler is suitable for high pressure system. So, it is not because only reason is steam is passing through the tube and tube can withstand high pressure easily, and that is why this type of boiler is much more suited for the high pressure operation. Okay. So, to summarize today's class, we had started our discussion from the basic of this particular cycle, steam power cycle, and we have discussed why boiler efficiency is so important. From there we have understood that it is essential to understand different streams, flow of different streams inside the boiler, and why? Because if we understand the flow path of different streams of the boiler, then we can also modify the design. The entire objective should be to increase the boiler efficiency, which in turn will increase the overall efficiency of the plant. So, with this I stop here today, and in the next class we shall discuss about the fire tube boiler. Thank you.